Today we're going to hopefully review how to do scientific notation. I'm also going to review something I went over in class on million years before present and how to convert a large number from standard form into one of these notations. So scientific notation is a really easy way to write really large numbers or really small numbers. And when I say really small, I mean numbers that are below 0, smaller than 0. We do this because it's not that scientists are lazy. No, it's that they decided that by using powers of 10, scientists can create short ways to write really long numbers. So there are two rules to remember when using scientific notation. The first is that you are going to start off with a number between 1 and 9.999, and that number is then multiplied by a power of 10. So I have an example here, 23 times 10 to the 5th. This is not proper scientific notation. Can you see which rule it is violating? If you're thinking the first one, good job. It is not starting with a number between 1 and 9.999. If we wanted to make this proper scientific notation, we would actually put a decimal over here between the 2 and the 3. That would become 2.3, and then that would be a number between 1 and 9.999. So there are 3 steps to keep in mind when we are converting a number into scientific notation. The first step is that we need to place a decimal in our number that we are starting with. If you have a really tiny number below 0, you will already have a decimal in place. But sometimes you get really large numbers and there's no decimal because whenever we write numbers, we don't really put a decimal there. However, every number does have a decimal, so we'll just put that number there so we can see it. Step 2 is to move the decimal over so you have a number between 1 and 9.999. And then step 3 is to count how many spaces you move that decimal over, and that number of spaces actually becomes the number of your 10's exponent. Keep in mind though, when we are moving the decimal over, if you start with a large number, something like 100 million, you are going to be moving the decimal from the end. So normally we don't write the decimal at the end, but we could put it there. We would have to move the decimal to the left to become a number between 1 and 9.999. And then that would mean if we count how many spaces it moved 1, 2, 3, 4, 5, 6, 7, 8. It moved over 8 spots. That means we will have a positive exponent. If we start with a really small number, something smaller than, oh, you can't see this probably because my thing just popped up. Something smaller than 0, your decimal would start here between the 2 numbers. We need to move it after the 1. So if we're making a small number into scientific notation, you're moving the decimal over to the right. And that would mean that we'd have to make the exponent negative. Anytime you see a negative exponent, it is a sign for you that you are working with really small numbers. Okay, so let's practice. So we have a grain of an amoeba, and this is something microscopic, and it is only 0.3 millimeters in size, but if we write that out into meters, that actually becomes 0.0003 meters. That's a small number. So already in your head, maybe you're thinking about which direction you're moving this decimal point over. Step 1 says we need to move the decimal over to make this number a number between 1 and 9.999. So I will move the decimal over to the right to create 3.0. Step 2 is to count how many spaces I move that decimal point over. That number becomes the 10's exponent. I move that decimal 1, 2, 3, 4 spots over. And since it was to the right, I started with a small number and I moved the decimal to the right, my exponent will become negative. So 3.0 times 10 to the negative 4. All right, the Big Bang is a huge number. The universe was, quote, born. It's not actually, the universe itself is not living. There are living things in the universe, but it was essentially came to be 13,700,000,000 years ago, or 13.7 billion years. That's a big number. Let's make it shorter. So following the steps again, how do we put it in the age of the universe into scientific notation? We take that very big number, and I'm actually going to work with a standard form right here. I'm going to put my imaginary decimal here, and I'm going to move that imaginary decimal over so that it's between the first 2 numbers to create a number between 1 and 9.999. So I'm actually taking that decimal all the way over here. I'm going to put it in between the first two numbers. That will become 13.737. Now I want to keep that 7 there because that's an important number. That gives me a lot of information, but I don't need all those other zeros, so I can take them away when I write my number. Step 2 is to count how many spaces I move that decimal over, and the number becomes a second exponent. And since I have a large number and I'm going to move it to the left, I will have a positive exponent. So if I count how many spaces, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I should have 10 raised to the 10th. And that number becomes 1.37 times 10 to the 10. Here's a chance for you to practice doing this on your own. I have 3 large numbers here, and I would like for you to pause your video and just anywhere on a scrap piece of paper, write down how these numbers, convert them over to scientific notation, and let's make sure you have this set and ready to go. So go ahead and pause, and when you are done, you can press play to see what the answers are. All right, I'm going to give you 3 more examples, or 2 more. Go ahead if you feel like you want to practice this again. You have 2 other numbers, but instead, actually, this is a good practice for you to see if you can go the other way. So when you're converting backwards from scientific notation to standard form, just keep in mind that this exponent is going to tell you how many spots you're going to move your decimal over. And so we're always going to go the opposite way. And since these are positive exponents, keep in mind that you're trying to create large numbers. You don't want small numbers, you're trying to create large numbers. So you're going to move your decimal point over 5 times. So if I did this 1, 2, 3, 4, 5, what would that number look like? Here we go. Take a look, you'll see that if we put that decimal back at the end, we'd have to move it over 5 to get to 1.23, the starting number. And the same with 6.806, our decimal point would be all the way at the end here. If we move it over this direction to make a number between 1 and 9.999, we have moved the decimal over 6 spots. Now here's one more practice. This is a little bit of both, going into standard form and then coming back from standard form. So go ahead and pause the screen, and when you're done practicing, you can press play to see the answers. All right. So you just did scientific notation, and now we are going to cover how to convert a really large number like this into something we call mybp, or millions of years before present. We're working with timelines this week, and we are going to be writing events that happened millions of years ago. And it could get really tiring to write this number over, but more importantly, we might not have enough room to write all of these zeros. So there's a really simple way and an acronym that I want to make sure you understand and that you can use that's going to help make your life easier while creating these timelines. So this is how many years ago Earth was created: 4,600,000,000. Now there's a simple way of writing that using millions of years before present, this acronym MYBP. Present actually means today. And so today, if we're talking about something that happened today, that would mean 0 MYBP. We actually haven't been in the past at this moment. Oh, now we're getting complicated. But just know if something happened today, it is at 0 MYBP because we aren't going into the past today. We're at present. Now, if you look at these, we could write these really long versions of the numbers, and it would include a lot of zeros, or we can just use MYBP to stand for million. So when we take 1 million and we convert it to MYBP, it becomes 1 million years before present. The same with this number, which if we read it out loud, reads 237 million. These 6 zeros represent a million. But we can get rid of those 6 zeros by writing 237 MYBP, millions of years before present. And again, down here, I just did that example on the other page. I gave you the date that Earth was created, 4,600,000,000 years before present. So 4,600 million years before present can convert into 4,600 million years before present. Now, what's common between all of these? Maybe you figured this out. If we were to do some sort of math calculation, the way that we convert this large standard form into MYBP is simply by dividing by a million. Let's look at this. So if I have a large number like 27 million years and I want to convert it, I'm going to take 27 million divided by a million, cross off my zeros. I'm actually going to get 27. Add MYBP to the end of your number, and you have just converted to MYBP. Now, sometimes it gets a little tricky because you have a number like 27,030,000 and you need to convert that to MYBP. It's not going to be as easy to do that division I did on the other side. One, you can use your calculator. I'm okay with you doing that. Just plug this big number in and divide by a million. Or you can put a decimal at the end of your number, and if you think about the scientific notation conversions we just did, you are always, you will always just move the decimal to the left. The decimal to the left 6 spaces. So I'm going to move this decimal all the way over here 6 spaces, and my new number becomes 27.03. Now I don't need all these extra zeros, but so I can take those away, and now I have my new number 27.03. Add MYBP to the end, and I have just converted that number into millions of years before present. Here's another example. Sometimes we are looking at events that happened less than a million years ago, so they haven't quite reached a million years. Step one is, well, you could ignore all these steps if you just plug this into your calculator, 43,000 divided by a million, or you could divide this by moving the decimal places 6 spaces to the left and adding a 0 in front of any value you need to get to 6 spaces. So if I have my imaginary decimal here and I move it 6 spots over, well, I get to the end of the 4 and I still need to move it over. So 1, 2, 3, 4, 5. I need to move it 1 spot over, so I can. I'm just going to add a 0 in front. And now I have my new answer. If an event happened 43,000 years ago, that is the equivalent of saying that it happened 0.043 MYBP. Has not been a million years yet. So if you are taking a number from standard form and moving it to millions of years before present, you are just going to divide that number by 1 million. I did not go the reverse, which is taking in a number MYBP and moving it into standard form, but if you wanted to do that, you would simply just multiply your number by a million. You would do the opposite of what we just did. And that's how we that's all there is to converting between millions of years before present and standard. And next we'll do a little practice.